Bismillahirrahmanirrahim. Assalamualaikum. In today's video, I will discuss the remaining types of matrices. The first 6 types of matrices I have discussed in the previous video. Now I will start with the 7th one, that is negative of a matrix. The negative of matrix is obtained by changing sign of all entries of matrix. इस डेफिनेशन का मतलब ये है कि किसी भी मैट्रिक्स का नेगेटिव तब हम हासिल कर सकते हैं जब हम उस मैट्रिक्स की सारी एंट्रीज के साइन चेंज कर दें. हम इसको एग्जांपल के थ्रू भी सॉल्व करेंगे. वी सपोज सम मैट्रिक्स ए. सो बाय मल्टीप्लाइंग द नेगेटिव साइन ऑन द बोथ साइड्स, द साइंस ऑफ द एंट्रीज will become change. Positive 1 becomes negative 1, negative 2 becomes positive 2, and positive 3 becomes negative 3, and positive 4 becomes negative 4. So this is the negative of a matrix A. The 8th type is diagonal matrix. A square matrix is called a diagonal matrix if at least one of the entries of diagonal is not 0 and non-diagonal entries are 0. यहाँ पे हमें बताया गया है कि एक स्क्वायर मैट्रिक्स है. स्क्वायर मैट्रिक्स का मतलब है जिसके नंबर ऑफ रोज और नंबर ऑफ कॉलम्स जो है वो इक्वल होंगे. तो वो डायगोनल मैट्रिक्स तब होगा जब उसकी डायगोनल पे एंट्रीज मींस हेयर, डायगोनल पे एंट्रीज एटलीस्ट वन डायगोनल एंट्री जो है वो नॉन जीरो होगी, मींस 1 2 3 4, नॉट 0. And non-diagonal entries means that जो diagonal पे मौजूद नहीं है. For example, this one, this one, this one, this one, this one, and this one. So these non-diagonal entries are all 0. So we call it as a diagonal matrix. 9th type is scalar matrix. If all diagonal entries are same and non-zero, then it is called a scalar matrix. For example, we take a matrix B here. So we check that this is a scalar matrix or not. We see that the diagonal entries are same and non-zero. So we call it as a scalar matrix. The 10th type is identity matrix. If all entries on diagonal are 1, then it is called identity matrix. It is denoted by capital I. We take an example. Here we see that all diagonal entries are 1. So we call it as a identity matrix. The 11th type is symmetric matrix. If square matrix is equal to its transpose, then it is called a symmetric matrix. Here is the condition of the symmetric matrix, that if the matrix is equal to its transpose, then we call a matrix a symmetric matrix. We take an example. We suppose the matrix A. So according to condition, we have to take the transpose of the matrix. So we take a transpose by changing rows into columns or columns into rows. So we will get this matrix which is equal to the actual A matrix. So the condition is satisfied that A matrix is equal to A transpose. So then we call A is a symmetric matrix. We take another example. Again we take a transpose according to the condition. By taking the transpose, we will get this matrix which is not equals to the actual matrix M. So we say that M is not equals to its transpose. So then the M is not symmetric matrix. The 12th type is skew symmetric matrix. A square matrix A is said to be skew symmetric if it satisfies this condition, that is its transpose is equals to its negative. For example, we take a matrix A here. According to condition, we find a transpose of the matrix A. Then we find the negative of the matrix A. Transpose can be found by changing rows into columns or columns into rows. And negative can be obtained by changing the signs of all entries of the matrix A. So here we see that the A transpose and the negative of A is equal. So the condition of skew symmetric is satisfied, that is A transpose is equals to negative of A. So we can say that A is a skew symmetric matrix.